Hey ninth graders. All right, today we are going to talk about polygons, which is just a fancy word for shapes. So on today's notes at the end, you should have had these four shapes. I can't remember if it was that way or that way. It doesn't really matter, but what I'm gonna do, well, what I did do, is I cut these out and we are going to try to find if each of these shapes can be reflected or rotated back onto themselves. So I'm gonna start with the rectangle. And we have rectangle as this first item right here. And I also have a rectangle that I cut out. You'll notice all the shapes that I cut out were beautiful at one point, and then a member of my family, I won't say who, crumpled them and threw them in the trash can, so they're gonna be a little bit wrinkly. But I'm going to fill in some of these blanks, and we're gonna decide what sort of ways that this rectangle can be carried onto itself. So a line that reflects a figure onto itself is what we call a line of symmetry. So at the top here, that is called a line of symmetry. That's a line that can reflect a figure onto itself. Okay, a figure that can be carried onto itself by rotation is said to have rotational symmetry. And lastly, every four-sided figure is called a quadrilateral. Quad means four. All right, so let's talk about the rectangle first. A rectangle is a quadrilateral that contains four right angles. Is it possible to reflect or rotate a rectangle onto itself? So you're going to describe the reflections and or rotations that carry a rectangle onto itself. Be as specific as possible in your descriptions. So I'm going to go back to this rectangle. Is there any way that I can make this rectangle fold onto itself or spin onto itself? So what sort of reflections could I do with this thing? Well, I can see that this thing is symmetrical going across. So if I were to take the rectangle and fold it in half and crease it, open it up, that crease, the nice one, not the one that got thrown in the garbage, that crease is what we call a line of symmetry. Remember, a line of symmetry is a line that reflects a figure onto itself. So I have a line of symmetry that goes this way. That line will reflect this picture perfectly onto itself. Now, do you see any other lines of symmetry? Some people try to do a line over here. If I were to use a line over here, see how that doesn't perfectly land on itself? So I couldn't have a line of symmetry on that side. All right, well, I could do a reflection though, and I could fold it this way. So here is going to be a second line of symmetry. If I fold it this way, crease it, and unfold it, wow, look, the first line reflected it onto itself, so the first line was a line of symmetry, and the second line reflects the rectangle onto itself. It's also a line of symmetry. So there are two lines of symmetry that we could put on here. Are there any other lines of symmetry that could reflect this shape onto itself? Now, some of you might be thinking, well, we could go from corner to corner. Let's try that. If I go corner to corner, seems like it should work, and then you realize pretty quickly there's no way this works, but it does look like a cute little cat. But no, it doesn't work. If I try this one, it doesn't work. There's nowhere else that I could reflect this thing that would make it land on itself except there and there. Okay, so when I go back to this, it said, describe the reflections and or rotations. I'm going to take a straight edge and I am going to draw in all of the lines of reflection. And how we are going to draw those, I'm going to have to eyeball this because I know that one of them was this way, remember? And we're going to draw those as a dashed line. Okay, so there was one line of symmetry. Remember, we folded and it landed perfectly on itself with that vertical line of symmetry. And then we also had a horizontal line of symmetry that went this way. It's like weirdly difficult for me to draw a dashed line. Okay, so my vertical and my horizontal lines of symmetry. Okay, let's try to talk about rotation now. Describe the reflections and or rotations that carry the rectangle onto itself. So what does that mean about rotations? Well, if I go back to this rectangle, how far do I have to spin the rectangle for it to land perfectly back onto the rectangle? So if I take this rectangle, if I spin it, let's go 90 degrees. 90 degree spin would be like this. That's a quarter turn because this side over here is now pointing down. Did that rectangle land perfectly back where it was? No. Okay, so if I go back, what's after 90? I could go half a circle. I could go 180 degrees. So if I take this thing and I spin it, does it look like it's in the same position as when it started? Does everything line up nicely? Yeah, it does. We've got 4 right angles, the long end, short end, and we know that these opposite sides are the same length. So when I spin 180 degrees, it maintains the same size and shape. Okay, so I'm gonna call that rotational symmetry. I'm gonna skip a little space. Oh, that's a really light green. We're not gonna use that. Too light. Okay, we'll go with the darker green. I got some new pens. I'm really excited about it, but I suppose people who get excited about pens probably aren't that cool. Too bad, I am cool and I get excited about pens. So rotational symmetry, and we said that one of the angles of rotational symmetry, 90 degrees did not work, but 180 degrees did make the rectangle land back on itself. That little 8 that doesn't connect was really bothering me. I fixed it. I'm sure it was bothering some of you guys. I know it was bothering you, Justice. All right, so if we've got this rectangle, 180 degrees will make it land right back on itself. But there's another spin that will make it land back on itself. It's like the cheater spin. How far do you spin it where it lands exactly where it started? That's gonna be a full circle. That's gonna be 360 degrees. That always works. 360 degrees. Okay, so our rotational symmetry was 180 degrees because I could do half a spin and the rectangle landed back where it was. And I could also do 360 degrees because it would be a full spin to get back where it was. There's one other thing I wanted to write on here. It was about the lines of symmetry. We had up here for lines of symmetry, there were 2. There were 2 lines of symmetry. Okay. It said describe them. They're beautiful. Just kidding. I would say horizontal and vertical, but we'll be okay. All right, let's go to the next shape. A parallelogram is a quadrilateral, that means 4 sides, in which opposite sides are parallel. Is it possible to reflect or rotate a parallelogram onto itself? Okay, so let's go to our parallelogram. Now, there are 2 shapes that look slanty. One of them is a parallelogram, one of them is a rhombus. Here's how you can tell. A parallelogram is like a smushed rectangle because only 2 sides have to be the same length and the other 2 sides are the same length. A rhombus is like a smushed square where all 4 sides are the same length but it just got smushed sideways. So we're gonna save you for next time, rhombus. All right, let's just look at the parallelogram. So I want to see, are there any folds that I could do to make, it's like so wrinkly, to make this parallelogram land back onto itself, to make it reflect onto itself. Let's try the one that we used for the rectangle. Down the middle. No, it didn't line up. Look at that. How cute and adorable the little like kitten ears. But no, it did not work. So we can't do a vertical